Okay, we spent a lot of time on regular linear velocity motion, but now we're going to start going into some units where we're talking about rotational motion. We've talked about circular motion, but we're going to now talk about rotational motion. So we need to understand the difference between this. Let's look at this circle here, and let's say that this is like a merry-go-round or something that we're looking down on that is that's rotating around like this. Let's say it's spinning. Okay, and let's say there's people sitting on here. We'll say here's the center, and let's say that there's a person here, and let's say there's a person sitting on here. And I might ask a question. I might say, this is person one, this is person two. Which person is traveling the fastest? Well, that's kind of a tricky question, because if I say which one is rotating the fastest, well, they're both on the same thing that's rotating. So whatever the speed is that this thing's rotating, they're both rotating that fast. They would both go all the way around, all the way around. This one person would come around like this, and this person would come around like this, and in the same amount of time. But which one's going faster? Well, this person out here would travel a lot further in the same amount of time that this person would. So this person out here that's further out is going to go faster velocity in meters per second than this one would. But they could have the same, what we would call rotational or angular velocity. They would both be going however many revolutions per second. Okay, so we have been talking about velocity, regular circular motion. So these two things, you can talk about circular motion on this one and this one. But we're going to talk about rotational motion for the actual disk that they are both on. So what we want to talk about a little bit is what is a radian, because we're going to have a lot of things that we're going to talk about how many radians something turns. A radian isn't as difficult as people make it out to be. I think you just kind of maybe somewhere along the line have been using radians and you just kind of forgot what exactly it was. A radius is the distance from the center out to the edge. That's called one radius distance. It could be in meters or centimeters or whatever, but we're going to call it just R. It's going to be one radius distance. So as this line here sweeps out around this, as this thing's rotating, it sweeps out a path around here. What we're interested in is looking at the angle that it makes if this radius sweeps out the exact same length as the radius. So let's imagine that we measured from here out here to the edge, and we cut a length of string exactly that long. So a lot of the early mathematicians were interested in finding out, if I could cut a length of string this long halfway across the circle, how many lengths of those strings could I put around the outside edge? And when they did that, they found out that they could put just a little over 6 of those around the outside edge, which means if we measured all the way across, what we call a diameter, they could put just a little over 3. If I cut a string length from here all the way over to here to one diameter, I could put just a little over 3 of those string lengths around. At that time, we measured it as 3. A little while later, we measured it with more precision, and we had it as 3.1. So we started out with, we could say we could put 3 diameters of string lengths around the edge of the circle. Then we measured a little bit more precision, and we said, well, we could put 3.1 around there. It's not exactly 3, it's a little over 3. And we measured a little bit more precision, and we said, well, we can put 3.14 string lengths all the way around the edge. And so you'll recognize this now. We have a Greek symbol that we use to represent how many diameters we can put around a circle. And that Greek symbol, of course, is pi. So, and it doesn't matter what kind of circle you have. If you have a much bigger circle, you're going to have a bigger r, and it's still going to be just a little over 3 of the diameters to go all the way around, or just a little over 6 of the radians to go all the way around. So if I sweep out however long this string length is, if I make that string length and I put it right here on this circle, and I start it right there, and I start going around about the same length that this is right here, then that angle that it makes as I sweep out one string length of radian around here, and remember I can put like about 6 of these all the way around, the angle there that makes is called 1 radian. That's 1 radian angle. And so there'll be about 6 of these radian angles around here. And we know that it's easy for people to remember, I think, that in an entire circle there's what we call 360 degrees. Well, if there's going to be about 6 radians all the way around, then that means there's approximately a radian, an angle of a radian. 1 radian equals about, I'll say approximates, about 60 degrees. That's about 60 degrees for 1 radian. Technically, we're going to take 360 degrees and we're going to divide it by not just 6, but we know that we can get a little bit more 6 string lengths around this thing. We can get 6.28. So if we divide it by 6.28, or what you might call 2 pi, then you'll see that a radian is approximately, it's like a little, about 57.3 or something degrees for one of those radians there. So that hopefully is a good review there of what a radian is. We have an angle that we're going to keep in radians. So if I have, again, like, you know, a person right here, and I want to know actually how fast they're going. You know, what if this, you know, person goes from here all the way around, you know, and is traveling around and gets to here? Well, what they did is that they just traveled, you know, 1 radian, and maybe they're going, I can talk about how fast this thing is rotating. It's rotating like 2 radians per second, 2 radians per second. Well, how fast are they going then linearly, like meters per second? Well, all I need to know, if they're going rotating at 2 radians per second, and I want to know how fast they're going in meters per second, well, they're going 2 radii per second. So all I need to know is how long is a radius. If a radius is like 4 meters, then I'm going to say that they went 2 radians per second times, and I can say there's 4 meters for 1 radius length, right? 1 string length, and that can cancel out, and I'm going to be going 8 meters per second. So all I need to know, if I know their rotational velocity, like how many radians per second they're going, all I have to do is take it times their radius to find out how fast they are actually going in meters per second. So hopefully that kind of explains what a radian is and how we can kind of convert it to actually meters per second.